Hey everybody, this is Larry. This is me going over day 11 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think. Gonna look at this problem. Rounded square. Given 4 points in space, 4 points in 4 square. Okay. So there are a lot of different ways you can do this. The tricky thing is kind of handling edge cases and just really defining your squares. The way that I always do it is just looking at the distances and the diagonals. So what I would have is something like okay, so points is equal to p1, p2, p3, p4, and then we could have like a distance formula that's something like AB, and that should return sub 0 minus a b sub 0 plus a sub. So this is just a normal distance formula, and then we just get all pairs of the distances. And given 4 choose 2, there should be 6 pairs, right? So 4 index in range of 4 for index 2 in range of index plus 1 to 4, and then we just have distances away is equal to distance of point sub index 2. So that's just now we have an array of all the distances that should have 6 items, and if you know, then as in a square, there are 4 equal sides obviously, but also the diagonal has to be different, right? Because otherwise, if you have a diamond, then the diagonals would not have the same distance, and also for obvious reasons, the diagonals would be larger than the 4 sides. So we could implement that just by doing something like that. Sorted if distance so this is now, so this is just four smaller distances are the same, and also and distances of 4 is equal to distances of 5, so, and the 2 diagonals. So that's basically, here is should be the 2 diagonals are the same. So then this is true. So we could just actually return this. That's pretty much it. Maybe we'll give it a go. They don't give you more examples. Usually I would probably test a lot. We could test at least 1 force cases. But I think the tricky part is that even though all the integers are on positive points, it doesn't have to be axis aligned, right? And what I mean by that is that it could be this, but then rotated in some weird funky way. So we have to make sure that as well. So for example, one case would be, let's see, 0, 1 at the bottom, 0. Can we do negative numbers? Yeah, okay. So then that means 0, 0 at the bottom, 2, 0 on top, 0, 1, and wait, is it? No, this is 1, 1 and negative 1, 1 or something like that, right? That should be true. This is a diamond, I think. Maybe well, okay. Maybe my diamond is drawn incorrectly though, but oh, this should be O2. Whoops. And you could draw these out. That's the beauty of these problems, is that you could make up your cases and then verify if they're right without needing the tester. I'm gonna give it a submit. Ooh. Oh. Okay, I guess that's fair. I guess there are more edge cases around length 0 places, and I guess we just have to check that the smallest distance is greater than 0. I think that's the only case there. I mean, there cannot be negative edges, but that's a good one. Okay, cool. So yeah, so that's pretty straightforward. There are 2 for loops, but because we always get 4 points, this is just over one time and or one space, because everything is over some function of 4, right? So yeah, let me know what you think. The thing that I would say for geometry problems is try to keep it as simple as possible, because there are a lot of ways to make mistakes. And for these things, I try to keep it an int as much as possible, which is why all the distance. I actually kind of lie. This is actually the square of the distance, right? So that I could keep things an integer, but because of this, we don't do any operations. That's okay. We could just square everything on everything. Yeah, a floating point is going to be a pain, and as you do more and more harder geometry problems, you're going to have to figure out how to deal with them. But for this problem, for now, it is okay. So yeah, let me know what you think. Let me know how you did it as geometry problem. There are a lot of ways to kind of represent these same ideas. Let me know how you did it, and I will see y'all tomorrow. Bye-bye.